Hello everyone, welcome back to another lecture video on dynamics of machinery. In this video, we will be studying or solving a problem on the static force analysis of 4-bar mechanism where it is subjected to disturbing couple. So in the previous videos, we have learned to solve problems where the mechanism is subjected to external forces. So here instead of forces, couple will be disturbing the mechanism from its static equilibrium conditions. So let's get into the problem. So here we have a 4-bar mechanism where torque T3 and T4 are the external things which are disturbing this mechanism and that are acting on the link 3 and link 4 and that are named as T3 and T4, whose magnitude as well as directions you can see in this one. T3 is acting in clockwise, whose magnitude is 30 Newton meter, and T4 is anti-clockwise on link 4 and its magnitude is 20 Newton meter. And you can construct this configuration diagram first where this input link T2 and you have to calculate the torque to be applied on this input link T2 to maintain it in equilibrium. So here you can construct the configuration diagram based on this. Link AB input link is of 300 mm, so that can be constructed at an angle of 60 degree with respect to horizontal. And the next fixed point D, that means the distance AD is given. AD is 700 mm, so you can mark the point D. Next, from point B you can take a distance of distance AD is 800 mm and you can take a distance of BC equal to 700 mm, so you can cut an arc. And the length CD is given 400, so you can cut an arc, then you will be getting the point C. So in this way you can construct the configuration diagram for this 4-bar mechanism. Since the external disturbing things are torque and that are 2 in numbers, that means T3 and T4 are acting, so you will have to apply the principle of superposition. So here if you are applying the principle of superposition, this will be coming as 2 sub cases where this total number of external disturbing torques are 2. So this is representing the main problem and that can be divided into 2 cases where the effect of only one torque, that is T3, is taken, and then you can take the effect of the another torque acting individually, and at that time we will be neglecting the other one. That means when effect of T3 is taken, T4 will be neglected, and when T4 is taken, the effect of T3 will be neglected. So you can divide this main problem according to superposition method into 2 sub cases, and we will be solving these 2 sub cases. Then we will be evaluating the torque to be applied on link number 2, that is link AB, and we will be finally adding this factorially to get the required value. So first we will be solving the first sub problem or sub problem A, where the effect of T3 only is taken. So here you can see the configuration diagram as well as the components I have drawn separately, and this is required for drawing the free body diagram. And our first step will be to identify the type of members based on this one. So here if you are seeing, link number 4 will be a 2-force member since there is no external force acting, and also we are having, it is making connections this link 4 with 1 and link 3. So this will be a 2-force member and those 2 forces I will be naming. So this is a 2-force member and those 2 forces are F14, force exerted by 1 on 4, and F34, force exerted by 3 on 4. And the link number 3 will be a 2-force and 1 torque member because on that link an external torque T3 is coming, and I will be naming those 2 forces and 1 torque. So those 2 forces are force exerted by 4 on 3 F43, force exerted by 2 on 3 F23, and the torque, external torque acting T3. And now we have to evaluate the torque to be applied on the link 2. So automatically this will be becoming a 1 torque and there is no external forces. Forces are coming only from the neighboring links, that is link number 1 and link number 3. So this will also be a 2 force and 1 torque, and that I will be naming those 2 forces, that are F32, force exerted by 3 on 2, and force exerted by 1 on 2, and the torque to be evaluated, and I will be naming that torque as torque to be applied on link 2 for the sub problem A, so T2A. And this thing we have to evaluate where this T3 is the external torque whose magnitude is given. So based on this condition of members, we will have to draw the free body diagram. So first we will be starting with the simplest one. Here simplest link is the 2-force member where 2 forces are F14 and F34. So I have drawn this link 4 separately here, or link CD. So these 2 forces magnitude you are not knowing, but direction you are having from the equilibrium conditions of a 2-force member, that 2 forces should act in a same line, and that line of action will be taken as along this direction of this link. So those two forces will be coming in this direction. So I will be marking those two forces, and this will be the line of action of one force, and the other line of action will be coming that are in the same line along the link. And I can mark, but I am not knowing the directions. This force can be named as F34, force exerted by 3 on 4, where this 4 is the output link or CD, and this is the force that is coming from the ground, that is F14. So line of action you are knowing. And next link 3, that means this link is BC is a 2 force and 1 torque member. That 2 forces and 1 torque are this one, and you are knowing the equilibrium conditions. Those two forces should act in a parallel direction but in the opposite sense, and their magnitude should be same. So those two forces are F43, and you are knowing that this F43 is like action and reaction with respect to F34. So the direction of F34 should be same as the direction of this F43. So F43 if you are getting, then that should be parallel to the F23 coming, and then there will be a perpendicular distance, and that force into perpendicular distance will be giving you the torque that is acting, that is T3. So now I will be transferring the line of action of F43 to this one. Then you will be getting the line of action of F43. So first I will be marking. So the line of action parallel to F34 will be coming in this direction. So this will be representing the line of action of F43, which is equivalent to F34. Since this is a 2 force and 1 torque member, those two forces should be parallel. So the next force that is coming at the other end, that is from the link 2 or the force F23, will be coming in this way. So now we are having those two forces which are parallel, and here the external load acting on the link 3 is given, which is clockwise, and whose magnitude is also given, T3, whose value is equal to 30 Newton meter. So from this configuration diagram, this T3 for the static equilibrium condition of a 2 force and 1 torque member, this torque T3 magnitude should be same as the force, either of force F43 or F23 into the perpendicular distance that you are measuring. So this perpendicular distance you can call it as H1, that you can measure from the configuration diagram, and you can use the scale which you have used for constructing the configuration diagram, and you can multiply. And this torque is acting in the clockwise sense, so the couple formed by this pair of forces should act in the opposite. Then that means the couple should be created in an anti-clockwise way, so that the arrow head of this forces should come like this. Then only this pair of forces will be creating an anti-clockwise couple, which is opposite to the external clockwise couple T3. So here you can get the value of H1, and T3 value is already there. So from this H1 and T3 you can find the value of F43. So here if you are measuring from the configuration diagram and converting it into scale, then you will be getting this H1 as 670 mm or 0.67 meter you will be getting. So T3 was given as 30 Newton meter. So from this you can evaluate this F43. So F43 value will be equal to 30 divided by 0.67. That means F43 you will be getting as 44.8 Newton you will be getting. So this is the value of this F43, and this can be taken to the next link. So next link is actually link AB. So link AB is shown here. Link AB is a 2 force and 1 torque member. Those two forces are F32 and F12. So this F32 can be taken in the same way with respect to F23, like action and reaction. And from the link 3, this F43 and F23 are same. So this value of 44.8 Newton is applicable to F23 also, and that F23 will be same as F32. That means the value of F32 is equal to F23, and that is same as F43, whose value is 44.8 Newton. So now we are having the arrowhead which are acting. So the vector F23 will be acting in this way. So this is the direction of F23, and F43 will be acting in this direction. Then only they will be creating an anti-clockwise couple while the applied torque is clockwise. So F23, if F23 is acting in this direction, then F32 at the end B should act in this direction. So I'll be transferring that directions here. So this F32 will be acting in a direction in this way while arrowhead is coming like this, and you can name this force as F32, where the other force is F12. Since it is a 2 force and 1 torque member, the other force should be parallel and it should pass through the point A. Then the arrowhead will be coming like this, and that force will be named as F12. So now you can measure the perpendicular distance, and I will be naming it as H2, and here the value of F32 is 44.8 Newton, and this distance H2 you can measure from this diagram. Then that H you will be getting as 42 mm. 42 mm means 0.042 meters. So here if you are seeing, we will be looking for the direction of this couple to be applied on link number 2, that is T2A. Here this pair of forces F32 and this F12 will be creating a clockwise couple. So in order to balance that one, we will have to apply the anti-clockwise couple, that is actually this T2A. So the direction of T2A will be coming in this one, and that I will be naming as T2A. So you can evaluate the value of T2A as F32 or F12 into the perpendicular distance H2. Here this value will be getting F32 is 44.8 Newton into H2 is 0.042 meter, that you will be getting after conversion from this diagram. Then that is equivalent to a value of 1.88 Newton meter. This is the first answer, or the answer that you are getting from the sub problem A, by considering the effect of T3 alone and drawing the free body diagrams according to the type of member. So 1.88 Newton meter will be required to be applied on the link 2 or the input link to maintain it in equilibrium when this external torque T3 is acting on link 3. So this is the solution of sub problem A. Next we will be solving the sub problem B, where the effect of T4 only is taken. So this is the second case where the effect of T4 only is taken, and first step will be to identify the type of member. Here this link 3 will be a 2 force member, and I will be writing like this, and I will be naming those two forces. Two forces are F43 and F23. Next, the link 4 is subjected to an external torque, along with it is making contact with other two members. So this will be a 2 force and 1 torque member. Those two forces, you can name it as F14, F34, and the torque T4 which is acting that is actually the external torque. And here also you have to evaluate this the balancing torque to be applied on this link 2. So this will make a 2 force and 1 torque member. Those two forces are F32, F12 from the links 3 and 2, and also the torque T2B. For this sub problem you have to evaluate. This is the thing we have to evaluate at the end of this problem. For drawing the free body diagram, I have isolated and drawn the each of this link which is coming in this mechanism. So I'll be starting with the simplest link. Simplest link is the 2 force member, where forces are F43 and F23, and that will be acting along the same line. So I can draw the line of action, but I am not knowing the direction. So this will be the line of action of one force, and this will be the line of action of other force. Since this C is the point where link 3 and 4 is making contact, so this will be the line of action of F43, and at the other end contact with the link 2 is made, so this will be the line of action of F23. And the same thing can be transferred to link number 4, where link number 4 is a 2 force and 1 torque member, where forces are F34. So F34 and F43 are like action and reaction, so this same line of action can be taken to this link also. So since it is a 2 force and 1 torque member, the other force will be parallel to this F34. So F34 and F14 will be acting in the parallel way. So you can mark the direction of this F34 and F14 will be parallel, but now you are not knowing the direction, but we can evaluate that, because here the external torque is given in the anti-clockwise direction, that is T4, whose value is 20 Newton meter. So the couple produced by the forces F14 and F34 should be then clockwise, that will happen only when the forces are acting in this way. So if forces are acting in this way, then this will be creating a clockwise couple which will be opposing the anti-clockwise couple applied. So you can give the directions to this forces. This force should act in this way, and this can be named as F14, and this force will be acting in this way, and which can be named as F34. And the perpendicular distance you can measure from this one, and that I can call it as H3. So from this configuration diagram you can measure the value of this H3 and you can convert it into scale. Then that value you will be getting as 383 mm or 0.383 meter. So here the value of T4 will be equal to either of the force F34 into this perpendicular distance H3. So this T4 is 20 Newton meter and this H3 now it is 0.383 meter. So this is 20 Newton meter. From this you can evaluate the value of F34. Then you will be getting the value of F34 as 52.2 Newton. So this F34 is 52.2 means this F43 will also be equal to 52.2 and this F23 will also be equal to 52.2 Newton. Since this F34 acting in this direction, F43 will be acting in this direction and F23 will be acting in this direction. So I'll be giving the arrowhead. So this is acting in this direction and this is acting in this direction. So now I can transfer the or construct the free body diagram of the last link, which is actually the last step in this problem. So now you can consider the link number 2 where the external forces are F32. Since F32 and F23 are like action and reaction, so their line of action should come in the same way. So you can construct the line of action of F23 which is parallel to F32, which is parallel to this F23 coming like this. Since link 2 is a 2 force and 1 torque member, the other force should be parallel and acting at this position. And now you can give the arrow head to in this direction and this force will be coming in this direction, and this force can be named as F32. This will be F12. The F32 value will be equal to 52.2 Newton, which is same as F12. So now you can measure the perpendicular distance between these two forces and I can call it as H4. And if you are measuring this perpendicular distance, this one, then this H4 you will be getting as 274 mm or 0.274 meter. So now if you are looking, this pair of forces F32 acting in this direction and F12 is acting in this direction, which will be creating a clockwise couple. To balance this one on link AB or link number 2, you will have to apply an anti-clockwise couple, which is actually asked in this question. And for this sub problem, we will be naming this as anti-clockwise T2B for this sub problem. So you can evaluate the value of T2B, which is equal to F32 into the perpendicular distance H4, which is equal to 52.2 Newton into 0.274 meter. So this will be getting as 14.3 Newton meter. So now we have solved the second sub problem also. So here 14.3 Newton meter torque or couple in the anti-clockwise direction to be applied to maintain the system in equilibrium when this external torque T4 is acting. In the first case, it was 1.88 in the anti-clockwise direction. So now you can go for the final step to find the required torque to be applied on the link 2 or link AB. So the final resultant torque to be applied on the link AB can be found by adding this one vectorially. Since both of this torque to be applied are anti-clockwise, you can directly add one. In T2A value is 1.88 Newton meter and in the second case you obtained 14.3 Newton meter. So now you can add both of this, then you will be getting it as 16.18 Newton meter for this total problem or for the main problem, which is to be applied in the anti-clockwise sense. So this is the complete solution. So we have solved we have analyzed the static force analysis of 4-bar mechanism where the disturbing thing is couple which is acting on two links. So we have applied the principle of superposition and this is the final answer. So hope you understood this one and thanks for watching.